Hi everyone, this lecture 5 part 2 is about problems on vectors, additional problems on vectors as applied to statics. So in particular, we'll have orthogonal component of a force, moment of a force about a point or inclined axis, perpendicular distance between two vectors, and force components by dot product. So problem 1, compute the orthogonal components of the force F 3I plus 4j minus 12k in the direction of the vector 4I minus 6j plus 10k meters. So this is in newtons, and that distance, directed distance, is in meters. Orthogonal components of a force is the component in the direction of the other. So that is F cosine theta, where theta is the angle between them. So to illustrate, let us say this is the force vector and this is the distance vector. And assuming they are not perpendicular to each other, and there's a gap between them, their lines of action. So we draw a line parallel to D through F. That's the free vector of D. Then this free vector of D makes an angle of theta with the force, and the force can be resolved into two components, one in the direction of the free vector, the other perpendicular to the free vector. So this is the 90-degree line, so that we can now compute the orthogonal component of f in the direction of the other vector. So this is the perpendicular distance between the two vectors. So d sub t, this is used in computing distance between two vectors. In the last problem, we'll have to compute for perpendicular distance between two vectors. So this is the orthogonal component f cosine theta, and the other component is used to compute this perpendicular distance, which is f sine theta. So f sine theta is perpendicular, that direction is perpendicular to d sub d. And this orthogonal component of the force is also perpendicular to d sub d. So the moment of the force in the direction of D, or the moment of the force about directed line D, is equal to, by right thumb rule, position your right thumb towards the positive D direction, and the moment would be positive in this sense. But because f sine theta is in the opposite direction, opposite sense, so the moment is negative. So that's why we have negative f sine theta times d sub t. Of course, this magnitude is also negative in the actual, so that we can compute d sub t to be positive. Now, as I said, this will be discussed in the last part of the problem. So f cosine theta, orthogonal component of f in the direction of d. So that's simply dotting f with d. So f dot d is magnitude of f, magnitude of d times cosine of theta. So f cosine theta, which is our objective, is f dot d divided by magnitude of d, or f dot lambda of d, because vector d over its magnitude is lambda of d. So substitute, writing lambda of d as 4i minus 6j plus 10k over its magnitude, square root of 4 square, 6 square plus 10 square. So the value would be negative 132 over 2 square root of 38. That is 3 times 4 plus 4 times negative 6 plus negative 12 times 10 divided by this magnitude. So solving for f cosine theta in decimal, it's negative 10.71. So that's the answer. Problem 2, compute the component of the force F equals 12I plus 5J in the direction U and V axis. So this is the figure, then we can actually compute the angle of F with the positive x-axis because the components are given. Then F magnitude is square root of 12 square plus 5 square equals 30 newtons. So the component of F in the direction of U is F, magnitude of F cosine of this angle here. So tangent theta F equals 5 over 12. So theta F is 22.62 degrees. Then we can now compute this angle. So we form a right triangle beta, and the component of F in the direction of U is F cosine of beta, where beta is 90 degrees minus theta F minus 30 degrees. So it's it. Likewise, FV is negative, while FU is positive because it is in the direction of U axis. So beta is 90 minus 30 degrees minus theta F, 22.62. So beta is 37.38 degrees. So therefore, FU is 13 cosine of beta by the basic approach, scalar approach. So FU is equal to 10.33 newtons. Likewise, negative FV is equal to 13 sine of beta. This one, they are equal. So F sub V is equal to negative 7.892 newtons. Now, with regards to dot product, we have to obtain the dot product of F and U, where U, the unit vector of U is, since this is 30 degrees, so it makes an angle of 60 degrees with the x-axis, positive x-axis. Therefore, the unit vector of U is cosine of 60I plus sine of 60J. So FU is F cosine beta, as I said. So F dot lambda of U is, by that product, F lambda of U cosine of beta, but the magnitude of U is 1 because it is a unit vector. We are looking for F cosine beta, which is the component of F in the direction of U, or simply FU. So we obtain the dot product of F and the unit vector of U, where the unit vector of U is cosine 60I plus sine 60J. So since the product is sum of product of corresponding components, so 12 times cosine 60 is 6, plus 5 sine 60 is 2.5 square root of 3. Then expressing that in decimal, that's also 10.33 newtons. Likewise, F sub V in this direction is F, F dot lambda of V. Since this is 30 degrees, the angle it makes with the positive x-axis is 150 degrees. So the unit vector of V is cosine 150 degrees I plus sine 150 degrees J. So this is the angle between F and V. So F cosine of theta is the component of F in the direction of V. So F dot lambda of V is F lambda of V cosine theta. Lambda of V is 1. So F cosine theta is the component of F in the direction of V, where lambda of V is cosine 150 degrees I plus sine 150 degrees I. So substituting, so 12 times cosine 150 equals negative 6 square root of 3, and 5 times sine 30 is 2.5, and equals F cosine theta, or the component of F in the direction of V, or simply FV. So it is negative 7.892. So let's proceed to example 3. We solve the vector C with magnitude 10I with value 10I plus 11J minus 2K newtons into two vector components, one parallel to and the other perpendicular to the other vector D with components 12I plus 5K. Express each of your answer as a magnitude multiplied by a unit vector. So since these two directions are mutually perpendicular to each other, so the diagonal is simply the tangential component plus the normal component. Of course, the, the tangential component is simply vector V that vector V cosine of theta. So we obtain the dot product of these two vectors. So C dot D is CD cosine theta, where the tangential component is equal to C cosine theta. So this is D cosine theta. In vector form, we multiply that by the unit vector of the tangential direction. So C cosine theta is equal to C dot D over D, but D over D is vector D divided by its magnitude is the unit vector of D. So C sub T, or the tangential component, is simply C dot lambda of D. But because this is a magnitude scalar, to make it a vector, we multiply it further by the unit vector of the direction D. So C dot D is equal to 10 times 12 plus negative 2 times 5 divided by its magnitude, which is magnitude of D is 13, square root of 12 square plus 5 square. Then the unit vector of D is its vector divided by its magnitude. So simplifying, C sub T equals 8.462 times the quantity 0.923I plus 0.3846K. This is the unit vector. So that's the answer. This is 12 over 13 plus 5 over 13. That's the value. And this value in brackets is equal to 8.462. So we now substitute it here. So C is equal to C sub T plus C sub N. So this is vector C, this is C sub T, and plus C sub N. So combining like terms, we have C sub N equals 2.189I plus 11J minus 5.254K. So express again this in this is in vector form. Then we divide this by, we compute the magnitude, then multiply it by the unit vector. So the magnitude is 12.39, then copy the original vector, divide by the magnitude 12.39, then 2.189 divided 12.39 times 12.39. So 12.39 times quantity 2.189 over 12.39 is 0.167I. 11 over 12.39, 0.8878J, and negative 5.254 over 12.39 is negative 0.4241. So that's K. That's the answer in vector form. And we follow the condition that we have to express the answer as a magnitude multiplied by its unit vector. Problem 4. We solve the force F to quantity 200I plus 300J plus 500K newtons into two components, one perpendicular to plane ABC and the other lying in the plane ABC. So because this force is in the first octant, then we must define a vector perpendicular to this plane. So there are three ways to define that vector perpendicular to the plane, but I will only present one. So it should be AB, vector AB cross AC. So AB cross AC is a vector perpendicular to the plane. Then we divide that by the magnitude of that resulting vector. So vector AB is negative 3I, positive 8J. Vector AC is negative 3i, positive 4k. Then let's obtain the cross product. So negative 3i plus 8j cross quantity negative 3i plus 4k. So it is equal to negative 3 times 4 because I cross I is 0 is negative 12, then I cross k, then we have 8 times negative 3 is negative 24, j cross I is negative k, then 8 times 4 is 32, j cross k is I. Simplifying, AB cross AC equals 32i plus 12j plus 24k. So the lambda n is equal to this divided by that magnitude. Square root of 32 square plus 12 square plus 24 square. So lambda n in decimal is 0.7663i plus 0.272873j plus 0.5747k. So we can now compute the component of the force perpendicular to the plate by dot product. So assuming this is the normal vector and the angle between them is theta, so that component perpendicular to the plane can be computed by dot product. So F dot lambda of n. So Fn is F lambda of n, or this is the magnitude, and by dot product F lambda of n cosine theta, where lambda of n is equal to 1, the magnitude, then F cosine theta is Fn. So Fn therefore is 200i plus 300j plus 500k, the force, then dot lambda of the normal. The result is 200 times 0.7663 plus 300 times 0.2873 plus 500 times 0.5747. So F cosine theta is Fn is 526.8. And let's express this in vector form to compute the tangential component. So for the tangential component, so this is now the vector form, the magnitude of Fn that or times the unit vector of n, lambda n. So Fn in vector form is 403.7i plus 151.3j plus 302.8k. For the tangential component, since they are perpendicular to each other, the components, so F is equal to Ft plus Fn, or Fn plus Ft. So Ft, so substitute F equals Fn plus F sub t. Combine like terms, Ft equals negative 203.7i plus 148.7j plus 197.2k Newton. So that's the answer. So note that lambda n normal to the plane can be derived in three ways. One is AB cross AC, which is already done. The other one is BC cross BA. And the last one is CA cross CB. So the other one CA cross CB, and the other one is, the last one is BC cross BA. So that's lambda n. So let's proceed to the last problem. So problem 5, a force of magnitude 540 newtons is directed from A negative 354 meters to B 267 meters. So determine the perpendicular distance between the force and point C. Determine the moment of the force about a line directed from D to E. Then determine the perpendicular distance between the force and the line D. So this is the one I told you about, distance, perpendicular distance between two vectors. So for part A, so let's plot the points first. This is the force directed from A to B. So Let's express the force into its components. So it's B minus A. So B minus A, we have 5I. The direction A to B is 5I. Then 6 minus 5, 1. So J. Then 7 minus 4 is 3. So 540 times 5I plus J plus 3K. 7 minus 4 is 3. So 3K. Divide by the magnitude of the distance AB is equal to 5 square plus 1 square plus t square. So in decimal or in vector form, F is 456.4I plus 91.28J plus 273.8K. So let's transform it into components. Let's draw a box. Let's just transmit the force at A. You can also move it to B, but let's have A and C. So these are the components, and delta X, so this is point C. So delta X is uh, 1 minus negative 3 is 4. So it means C is in front of A. 4 minus 5 is negative 1. So it means along Y. So C is left of A. And negative 6 minus 4 is negative 10, which is this. So means C is below A. So this is the relative position between point A and point C. So that by right thumb rule, summation moment or mcx is equal to, this is the positive sense of moment cx. So it's 273.8 times 1 minus 91.28 times 10. So mcx, 273.8 times 1 minus 91.28 times 10, so negative 69 Newton meter. NCy, by right thumb rule, position your right thumb. This is the positive sense of NCy, this is the arrow, like that. So 273.8 times 4 plus 456.4 times 10. So 5659 Newton meter. Then MCZ, position your right thumb towards the positive Z axis. So both of these components are negative. So negative 456.4 times 1, then negative 91.28 times 4 is 456.4 times 1. So negative 821.5 Newton meter. The magnitude of MC, or in vector form, MC is equal to this value, X, Y, and Z components. So that's the answer to part A. Then determine the perpendicular distance between the force and point C. Since we can compute the magnitude of moment of the force about point C, and the magnitude of F is 540, so moment about C equals 540 times perpendicular distance to C. So that's it. So this is the alternate solution if you want to compute moment of the force about C. RC to A, you can also have RCB cross F. So I'll present RCA cross F. So C to A, so it should be A minus C to A direction. So A, negative 3, minus 1 is negative 4. Then 5 minus 4 is positive 1. 4 minus negative 6 is 10. So that's why these are the components of the position vector R sub CA. Then components of force, unit vectors. Then copy the first two column elements. Then apply product diagonal. So 1 times 273.8 minus 91.28 times 10. So you will get the same result. For J, 10 times 4, 56.4, which is that, minus 273.8 times negative 4. So plus, which is that. So 5659. Then for K, negative 4 times 91.28, which is this, and minus 456.4 times 1, this is that. So same result. MCF magnitude, moment of F about C, its magnitude is equal to sum of squares of its components. So M sub CF is 5753.9. Then equate this to magnitude of force 540 times perpendicular distance D sub C. So D sub C is 10.66 meters. So that's the perpendicular distance. Then determine the moment of the force about a line directed from D to E. So let's locate DE. So uh, RDE, the position vector DE is E minus D. So negative 4 minus 5 is negative 9I. Negative 6 minus negative 3 is negative 3J. 5 minus 2 is positive 3K. Then the unit vector is vector divided by its magnitude. So that we can use the formula moment about DE directly as uh, RDE cross the force, then time dot lambda DE. So MDE is RDA cross F dot lambda DE. It is also equal to REA cross the force, then lambda of DE, and so on and so forth. It is also equal to RDB cross the force, then lambda of DE, or REB cross the force, then dot lambda of DE. So I'll just present RDA cross F dot lambda of DE, where RDA is A minus D, coordinates of A minus D. So negative 3 minus 5 is negative 8. 5 minus negative 3 is positive 8. Then 4 minus 2 is positive 2. Components of force, unit vectors of lambda DE. Then copy the first two column elements. Then proceed with product diagonal elements down to the right positive, then minus up to the right negative. So the result is negative 8 times 91.28 times 0.3015 is equal to that. 8 times 273 times negative 0.9045 is equal to this. Then 2 times 456.4 times negative 0.3015 is equal to this. Minus quantity negative 0.9045, 91.28 times 2 is negative 165.13. Then negative 0.3015 times 273.8 times negative 8660.41. Then 3.3015 456.4 times 8 is 1124. So simplifying, the moment is scalar negative 4073.0 Newton meter. So the reason why the moment of the force about DE is negative is if you position your right thumb towards DE, the sense of moment for it to be positive would be that you curl your four fingers. So this is the tail, this is the arrowhead. That's the positive. But obviously in this case, it's the opposite. It's like that. So that's why the moment is negative. Then also, F dot lambda of DE. So to solve for the component of F parallel to DE, which is F cosine theta. So cosine theta is lambda of F because magnitude of F divided by, vector F divided by its magnitude is lambda F. Then that lambda DE because this is 1. So lambda of F is equal to 0.84 52I plus 0.169J plus 0.50 0.70k. And that is, these are the components of F. You divide this by 540. Each of this divided by 540, that's the unit vector of F. Then this is the unit vector of dE. Then remember that that product is simply the sum of the product of corresponding components. So the result would be negative 0.6626, so 0.8452 times negative 0.9045 plus 0.1690 times negative 0.3015 plus 0.5070 times 0.3015. So that's negative 0.6626 inverse cosine. So theta is 135.31.5 degrees. So it's more than 90 degrees. So that's why the cosine is negative. So remember that the moment or the component of the force perpendicular to the direction dE is F sine theta. So the moment therefore is negative F sine theta times perpendicular distance to dE. So this is the component of force. It's negative because the moment is negative. Then this is the perpendicular distance between axis DE and the line of action of the force. Then equals the moment about axis DE, which is negative 4073 Newton meter. Magnitude of F is 540, so negative 540 sine of 131.5 degrees times distance, perpendicular distance to DE is negative 4073. Solving for distance between the line of action of force and DE it is equal to 10.07 meters. So this is from example 1 about distance between two vectors. So just look at the principle stated in example 1 so that you can have the idea how to solve that perpendicular distance. So as a challenge, you can solve m sub c again by the following. So solve d sub c by trigonometry, so cosine law, and solve one angle, then you can solve perpendicular distance. You just form a triangle ABC, then solve for the sides, and you can solve for d sub c by trigonometry. Then compute moment dE by this formula, the product between moment at D. So you solve for moment at D in vector form. Then dot it with the unit vector dE, or moment at E dot lambda dE. So that's the other two ways in computing for moment about axis dE. So I hope that you can follow the solution and you solve a lot of problems on statics, especially these challenging problems here. And in order for you to understand this, so you have to go through with the principles on vectors first, the application, so that you can follow the solutions here. So more lecture videos will be upcoming. I hope that you will continue to watch and learn from the lecture videos that I uploaded in YouTube. But before you go, thank you for watching and don't forget to subscribe.